All right, grade 11s. This is the second last concept for trig, and it's something called general solution. Now, it doesn't use trig graphs, but you can see I've put one here just to explain what this concept is about. Right, when we get back to school, we will be doing functions and we will do trig functions, but for now, all I'm doing is just using them to explain. All right, so general solution. The word solution means solving, so it's about equations in trigonometry. And for general solution, it's almost like we're doing a general term like in number patterns. So we're going to find a formula that applies to a certain situation in a trig question, and that little rule or formula can be used throughout for any situation within that question. All right, so I've drawn here y equals sine x. You learned about this last year. This has its domain is negative 360 to 360. So for those who don't remember what that means, it means I'm starting at negative 360, I'm going all the way to 360. We will be recapping trig functions, but remember its period is how long it takes to work with one sine graph, and here it's from 0 to 360 is one sine graph. One mountain, one valley is one sine graph. All right, so now this is a graph, y equals sine x. So on the next slide, I have drawn in, again, the y equals sine x, and I have put in y equals a half. Now, y equals a constant is a straight line, and it's this blue straight line here. There we go. So I've just made it a little bit darker. So the blue straight line is representing y equals to a half. So now, when I ask a question in maths of y equals a sine x, y equals a half, and then I say, where does sine x equal a half? It actually means that I have glued these two together, because y equals sine x and y equals a half. So where do their y values equal each other? So in other words, where do they cross? So it's there. If we carried on drawing, it would be somewhere to the right. We've got one here, and there would be more to the left. All right, so within this negative 360 to 360, there are 4 places where sine x is equal to the line a half, the value of a half. So now in grade 10, when you worked with these equations, we would tell you solve for x, and then we'd say to you, okay, use your inverse button on your calculator. So shift sine of a half, and that will get you, on your calculator, x would be 30 degrees. And we left it at that. That's because in grade 10, your brains are still trying to figure this whole trig thing out. And so we just worked from 0 to 90 degrees. But now we've expanded you a little bit. We now can see on the graph that from negative 360 to 360, there are 4 places. So how do we get all 4 of those answers? Well, we need to expand our view a little bit. And what about if I were to change it from negative 1,000 to positive 1,000? There's going to be a whole lot more places that these two graphs, these two lines are going to cut each other. So it's going to be impossible for us to mark down every single time that these graphs cut. So we're going to make a general formula. All right. So again, bear with me. This is brand new. When I have a look at this one here, that's going to be the 30 degrees. So your calculator will give you the first acute angle that these two graphs, these lines where sine is a half. And then you've got to figure out where's the next time it's going to happen. So the sine graph has a very definite up and down slope. So the up slope, we'd work it out by saying, well, where's the next up slope going to be? It's going to be after 360, because your sine graph does this. So that's 360. Right? And then it's going to start another sine graph at 360. So there it was at 30. The next uphill, going up, is going to be 360 degrees onwards, a period away. And then it's going to happen again, another 360 degrees. You're going to find that same upslope, that same crossover. Now we also have a downslope. This downslope one over here. So then that downslope to downslope would also be a 360. But how do we find what that downslope value is? Well, we're going to use our little trick that I've given you here. Just get to it. Get rid of all this. All right, so to get to our next upslope for the sine, you take what your calculator gives you. So that's shift sine of the ratio. The ratio was a half. Your calculator will tell you 30 degrees, and it's going to be 30 degrees plus every 360 degrees. So my next time it's going to cross over is going to be at 390 degrees. And for my downslope, though, my downslope is going to have a different formula. Can you see it's just before 180? 180 minus 30 is going to give me the downslope. So the upslope, you take the angle that your calculator gives you. In this case, it's 30 degrees. And you can hop any 360 degrees to find the next upslope. All right, I'll talk about what the K means now. And then for the downslope, okay, the downslope of the sine graph, it's going to cross that blue line at starting at 180 minus what the calculator has given you. The calculator told you that it's 30 degrees. And then every 360 degrees after that. So what's 180 minus 30? This value over here must be 150 degrees. So if we were to, again, draw out a sine graph, sorry, it's not a very pretty one. So there's the 30. The next one will be at 390. If this one's at 150, to the next down slope, we've got to add 360. So that's going to be 510, if I'm not mistaken. 510. Yes. All right. All right. So if I wanted to find then the next upslope, from 390, I'd add 360 again. And then from 510, I'd add 360 again. Why 360? Because that's the period of a sine graph. The sine graph starts to repeat itself every 360 degrees. Every 360 units on the scale. So the degrees is your units here. All right, so for sine, it's always upslope, downslope. Your upslope will be your angle your calculator gives you when you press shift of whatever number they're giving you. Here we gave you a half. So shift sine of a half gets you 30 degrees. Then from that point, you can hop 1,360 degree spaces. You're going to always find an uphill where these two graphs, the sine wave and the blue a half line, will cross each other. The downhill, the yellow here, the downhill will be 180 minus what your calculator gives you. And then from that point, every 360 degrees, it will find you the next downhill. So you can go to the 1,000,000th or 2,000,000th downhill, you'll be able to work it out. All right, but please don't forget that we also go backwards. So the same thing applies. So I can subtract 360. So 30, where's my next uphill? Let's go here. There's an uphill. So 30 minus 360, that will be at negative 330 degrees. And then 150, I'm going to subtract 360 degrees. And that's negative 210. So you can go backwards as well. So if you wanted, you could hop again. Let's go this way. So that's an uphill. That's the negative 330. I can go to the next uphill. And then for the downhill, I can go, there's the downhill we just said was negative 210. And then we can go to the next downhill. So we can keep going. Now, theoretically, we could go to negative infinity and positive infinity and see how many times the black curve, the sine graph, will cross that line, the blue line of a half. So we don't want to have to put down every single answer. So that's why we make a general solution, like a general formula. And so that's what these two are here. These are representing the general solution, let's say like your TN, your general term for sine. Now, we're not in number patterns, but it has the same effect. So for sine, you take the angle your calculator gives you when you say shift sign of the fraction or number, and you add K360. Again, I'll talk about the K now. Or you say 180 minus plus K360. So we had 180 minus 30 got us the 150. Or we just had the 30 plus K360. Now, it very specifically says that K is an element of integers. K is representing how many hops we're taking. So if I have 30 degrees and I hop one lot of 360, that's where I was hopping to get my next upslope. If I'm going to go 2 lots of 360, it means I'm hopping once and then twice to get to my next uphill. And then, so you could take 30 plus 2 lots of 360, which is 720. And so the next few uphills will be 390, 750, we could add another 360, 1110, another one, 1470. We can keep adding an extra 360 degrees to see where the next upslope crosses. But it has to be in integers because we can't work in half periods here because the graph is a full sine graph. But when we're working with our graph functions, we're going to see that there can be a period shift. The graph can change its period. So we will come across a couple of those when we're practicing, but we'll go into it in a lot more detail when we get to the trig functions section. All right, so the idea is here you get sine, cos, tan equal to a number, and we're going to be able to apply the correct rule for each of them to find the general solution, like the general term. So this is the general term for your sine graph. All right, so let's move on to the next one, and then we'll practice them, and you'll see them in use. Cos is super easy because a cos graph is very special. It is symmetrical about the y-axis. So if I draw a line here, everything to the right is the same as everything to the left. So if I wanted to know, so this is the same sort of example. Okay, so in this case, the blue line's representing the same thing. So where is our cos graph equal to a half? So in your calculator, you'll say shift cos. So your calculator will automatically do the following. And then it's going to say that x is 60 degrees. Now remember, that's just telling you from 0 to 90 where it crosses. So here's 0, there's 90. It's talking about that first crossover. So that first crossover of the graphs is 60 degrees. But we know in reality, a graph doesn't stop at 90. It's going to carry on for all of infinity. So the next slope that we're seeing here, now this is a down slope, is going to be 360 degrees later. Sorry, that's not a down slope. So a down slope would be beyond that point. So we would add 360 to get to our next down slope, which will be 420. But the upslope on this side, because cos is symmetrical, will be negative 60. So to get to my next upslopes, this is an upslope, next upslope, I'd add 360, and that's going to be at 300 degrees. All right, so we can do the same thing. We can hop forwards and backwards. So from this down slope, let's go backwards to this down slope. So 60 minus 360 is going to be negative 300. So we can work out specific points where they're going to cross within a given domain from negative 360 to 360. Here it's going to cut at negative 300 and 300, negative 60 and 60. So that's why everything is positive and negative of the same number. And so we work just with plus minus the number that your calculator gives you, in this case 60 degrees, plus k 360. Again, the k is an element of integers, meaning positive or negative hops going forward or backwards to find the next space. We can't go in halves, that's why it's an integer. Okay, again, when I get to the actual examples, hopefully it becomes a bit clearer. Tan is, I know, one of the least favorite graphs for everyone, but in this case, it's the super easiest to work with. Now, just note that tan has a period of 180. It starts repeating itself after 180 degrees. So here's 0 to 180. So a whole tan graph has a top arm and a bottom arm. And don't forget, it has an asymptote. Can't cross it. And it happens again at 270. And so it's saying that one start to the next start is going to be 180 degrees. One asymptote to the next asymptote is 180 degrees. Everything's 180 degrees for tan. All right, so if I want to find out where tan x is equal to a half, the way this graph is equal to my blue line, right? So there's my half. Then I'm going to say shift tan in my calculator. So my calculator is going to do this, tan of a half. So it's always the value you want to work with. And then it's going to give you, so shift tan of a half is 26.57 degrees. 6.57 degrees. So that's that first point. That is 26.57 degrees. To find the next place that the blue line cuts the tan graph, I can add 180. I can add 180 again. So that's two lots. So k here would be 2 lots of 180. Or I can subtract 180, or I could subtract 2 lots of 180 to get to the next time. All right, so the general term is just to give someone the formula, then you can fill in how far you want to hop using your calculators. All right, these examples are not in your textbook. These are separate examples. They are more in your textbook, but the problem with your textbook is they use a different method. The method I've just shown you is called the equation method. It is the quicker, easier way. You can just learn the equations off by heart and use them as is. The textbook uses something called the quadrant method. In the quadrant method, you have to, for each example, go back onto your class diagram and work with each situation specifically. And there's a lot of room for messing up. Whereas with the equation method, it's always the same each time. Okay, so please do not use your textbook examples to help you. Also, do not use the answers at the back of the book for the general solution exercises, exercise 9 to 13, because they're going to give you the quadrant method. I will give you separate memos for these questions. Please do not use the textbook for this. Okay, it's the only not nice thing about this textbook. Okay, but here's the same example that I started with. So let's show you how it's going to be set out. It says determine the general solution of sine theta equals a half. So it's saying where would a sine graph be equal to the number a half, a y value of a half. So because the sine graph is wavy, it's going to keep coming back over that point of a half on a graph. So for A, we'd write here, sine theta equals a half. Then we got to say in our calculator, shift sine of a half. Now you don't have to show this step, but it's nice for you to see it. Okay, plus k 360 degrees, or 180 minus that process plus k 360. Okay, so you don't have to show that. What I like to do is just go straight to the answer. Let's just get rid of all this. So my calculator tells me that shift sine of a half is 30 degrees. So that's my upslope plus k 360 degrees. So my next upslope will be 360 degrees after, or 360 degrees before, or units before 30 degrees. Or, always use an or, not an and. Theta is going to be 180 minus 30 plus K360. And so that's 150 degrees plus K360. Somewhere around, please just write that you know that K is an element of integers. So it's saying if you want to know where a sine graph cuts over the value of a half, start at 30 degrees, hop 360 degrees left or right, and that's going to give you the upslope ones. For the downslope ones, you start at 150 degrees and jump left or right. So now, for question B, they're saying to us, find theta if theta must be between negative 360 to 360 degrees. So it's like the example I gave you. So in other words, it's asking you not for general, but for specific crossover points. Right. So we know in our calculator, if I type in 30 degrees, does 30 degrees sit between negative 360 and 360? Yes, it does. So that one works. So in my calculator, I'm going to click 30 and I'm going to hop 360 from that. Then it gets me to 390. Does 390 fit between negative 360 and 360? No, it doesn't. So I can't use that one. So then I say to myself, okay, well, let's start subtracting. So I say 30 minus 360. I jump backwards and I get negative 330. That fits. Yay. So you don't hop, you hop one forward, you hop one back, and you see what fits. Then we go to the 150. 150, if I hop no 360s, so 0 times 360, I'm going to get 150, which fits between this given restriction of negative 360 to 360. So that one works. Now, if I were to take 150 and add 360, I get 510. So I can't hop forwards. I haven't hopped on 150, so let's try hopping backwards. I get negative 210. That works. So we have 4 answers that work for where the sine graph cuts the line a half. And that's what we had. If you go back in the video, you'll see there were 4 distinct red dots on the sine example between negative 360 and 360 where the sine graph cut the blue line. All right, so it kind of look like this. There we go. Okay, so it was at the 30, the 150, and then this was the barrier. We couldn't go beyond that, and it was over here, and it was over here. So 4 points where the graph cut the blue line. Okay, so I'm hoping this is becoming a bit clearer. Let's try another one. All right, so now it says determine the general solution of tan 2 theta equals negative 4. Now that 2 in with the 2 theta is not a problem. Tan 2 theta equals negative 4. You did this last year. Okay, so because tan has nothing added or subtracted or nothing multiplied in front, it's fine. You can go shift tan on your calculator of negative 4. So tan negative 1 on your calculator of negative 4. And the second you click shift on your calculator, you write in K 180 degrees. You do the general solution. The shift is the start of the general solution. So shift tan of negative 4 is going to get me 2 theta. That's my angle by itself. In the previous one, it was just theta. Now it's 2 theta. Is negative 75,96 degrees, always 2 decimal places, plus K 180. So it's saying to me here that if my angle was 2 theta, I start at negative 75,96. That's where the graph would cut the line negative 4, and then every 180 degrees after that. But this is not where we end off. We don't end off a question with 2x or 2y or 2 theta. We need to get theta by itself. It's being multiplied by 2, so we're going to divide it by 2. So you're going to divide negative 75.96 divided by 2 is going to get you negative 37,98 plus K never changes, but 180 also needs to be divided by 2. So it's saying that the graph has changed a bit. We're going to see a repeat of points every 90 degrees. There's been a period shift. Again, we're going to look at that when we get to the trig functions a little bit more, but the idea is that we're squishing our graph. We're seeing more of a graph in than we used to. It's now happening in 90 degrees, not 180 degrees. Okay. So now they're saying find theta, not 2 theta, theta if we need to work between negative 90 and 180. So in your calculator, you're going to type in negative 37,98. Don't add anything. Do you agree that it sits between negative 90 and 180? Yes, so that one's fine. The original answer is fine. But then now you are going to not add 180 or 360. You've got to add the jumps that apply to this question. So if I add 90, I get 52,02 degrees. Does that fit in the domain they gave us? Yes, it does. All right. Then you're going to add another 90. That's going to get you 142,02 degrees. Does that fit? Yes, it does. If I add another 90, I get 232, which falls beyond the 180. So we can't do anything else. So then I go back, I take negative 37,98 again in my calculator, and I subtract 90 from it. And I get negative 127,98. That falls out of the domain. Negative 90 is my limit. So these three answers are the only time my tan graph is going to cut in this situation. So imagine there's a line here and we've got some tan stuff going on, right? So it's saying to us between negative 90, right, and 180, it's going to cut at, oh, sorry, this is a bit off. Yeah. Like that. It's going to cut at negative 37,98. Then going to cut again at 52,02. And then it's going to cut once more. Let's just do that. So if that's my limit of 180, it's going to cut once more at 142,02. All right. The next time it will cut is obviously before the negative 90 and after the 180 again. All right. So I'm hoping this is clearish for you. Okay. This next example is just a new type, and this is where I'm going to be stopping with this type and then just talking you through some of the exercises. And then the next video will be about a very specific type of situation, and then we will move on to some factorization types. Okay, so just bear with me. There's a lot going on here. So this one says, find the general solution to the equation of 3 sine theta equals 2 cos theta. Okay, so now this is a situation where you have sine of an angle on one side. Doesn't matter what else is with it. Forget about the 3. And cos of the same angle. Do you see it's theta and theta? So they're both thetas, but one is sine, one is cos. This and this time only is when you can do the following. And you have to do the following. You divide both sides by cos of the angle. So if your sine and cos are on the same side, you've got to get them on separate sides. So once you can divide by cos, you're going to get 3 sine theta over cos theta equals 2 cos theta over cos theta. Right? What does sine of a cos equal? Equals tan. And what does cos of a cos equal? 1. But then it's still got that 2 there. So cos of a cos gets you 1. And so then I can get tan by itself. And once you're at this point, when you have tan, angle equals number, you can say shift tan on your calculator. Shift tan of 2 over 3 gets us 33,69 degrees. So theta is 33,69 degrees plus k, 180 degrees for tan. Don't forget to tell me it's integers. I think in the previous example I might have forgot to tell you that it's an element of integers. Please, you get a mark for that, so just try and drill it into yourself just to stick it on the end. Okay, so the second I click tan on my calculator, shift tan on my calculator, I'm going to put in the general formula for tan's general solution. All right, then the next one is asking us about, it's a new question, so example 3b is a completely new question. All right, it says sine theta plus cos theta equals 0, and we're supposed to solve for theta. Now, when you ever get something that's called solve, you always do the general solution in trig. So solving for anything in trig, general solution, but they've told us that they only want the answers that fit between 0 and 360. So now I recognize that I have a sine and a cos, but they're not on the same side. So kick them over, get them onto the same side. Onto opposite sides, sorry. You don't want them on the same side. They're on the same side, kick them to opposites. So the cos I'm kicking over, it's going to become negative. So now I've got sine equal cos of the same angle, so I can divide both sides by cos of whatever angle, theta, x, beta, alpha, as long as it's the same for sine and cos. So sine of a cos gets you tan, cos of a cos gets you 1, don't forget the negative. So then now I've got tan angle equals number, so I can say shift tan on my calculator of -1, and it gets me my angle by itself of -45 degrees. But I've clicked shift on my calculator, so we don't just want one answer, we want all the possible answers for -infinity to +infinity, k being an element of integers. Then, after we've done the general solution, then we can go back to our question and do the specific answers. So in your calculator, you type in -45. Ask yourself, does -45 sit between 0 and 360? -45. No, it doesn't. It's before 0, so we can't use that. But if I add, now remember for tan here, I'm adding 180 according to the question. I get 135 degrees. Does that sit between 0 and 360? Yes, it does. Then I'm going to add another 180. And I get 315. Does 315 sit between 0 and 360? Yes, it does. Now, logically, if I add another 180, you're going to see it's going to get beyond 360. It's going to be 495. It won't work. So we have two places where this specific graph crosses over a certain point. Now, it was a sine and a cos, and now it's become a tan. That's not too important. The idea is, though, if I were to graph this, if I were to now, instead of using the sine and cos, and I went to the tan theta equals -1, the tan graph will cross -1 at 135 and 315 in that given domain. If I were to go into my computer and plot this original as a graph, mixing the sine and cos, my computer will know that it's going to get me the equivalent type graph, and it's going to cut in those same two places. All right, so you don't need to worry about what a graph is going to look like at this point. All you need to worry about is following the rules. If you've got a sine and cos in the same question that have the same angle, theta and theta, beta and beta, 2x and 2x, then you divide by cos of that angle to get a tan. All right, there's going to be a situation where we'll get sine and cos with different angles, but that's for a different video. All right, we're just starting off with the basics. Graph. Okay, so now let's have a look at this one. It says trigonometric equations for which factorizing is necessary. Yes, I'm sorry, we're going to have to do factorizing here. Okay, so it's like imagine solving a trinomial or solving some sort of binomial where you have to factorize first. For example, if you had 3x squared plus x equals to 0, you might have to first say, take out an x, and so it'll be 3x plus 1 equals 0, x equals 0, or x equals -1/3. Okay, so that's the same sort of thing. We're just going to be working with sines and coses and tans. So for A, find the general solution. So you don't need to do all those specific hops, just the general one of 1 plus sine theta equals cos squared theta. Okay, the first thing I'm going to do is I'm going to recognize I have a squared, I have a sine, and I have a 1. So, but the squared is cos and the sine, well, the plain term is sine. So it's like having a y squared equals x plus 1. It's not a traditional trinomial. We'd rather need an x squared, an x, and a 1. So let's see if we can do that. So I'm going to move everything over. Cos squared theta minus sine theta minus 1. Is there a way for me to change, cos squared theta into something with sines? Yes, there is. Because we said sine squared theta plus cos squared theta equals 1. So what's to stop us from saying that? Cos squared theta is 1 minus sine squared theta, which we've said before. So 0 equals 1 minus sine squared theta minus a sine theta minus a 1. Okay, so let's fix this up. 1 minus 1 gets me 0. Negative sine squared theta minus sine theta, you can't change because they're different terms. I'm going to divide everything by negative 1. 0 divided by negative 1, 0. That's going to be sine squared theta plus sine theta. So that's like saying x squared plus x. I'm going to then take out a common sine theta. It's very much like the identities you've done. You're left with sine theta plus 1. So that means sine theta equals to 0 or sine theta equals to negative 1. So once you're at this point when you have sine angle equals number, so nothing added or subtracted to it, nothing multiplied, and on this side, so sine theta equals 0, sine theta equals negative 1, you can now click shift on your calculators. So shift sine of 0 is 0 degrees. So the angle we're solving for is theta, 0 degrees plus k 360 degrees, or the other version is theta equals 180 minus 0 plus k 360. So that's the upslope, that's the downslope. Study these formulas off by heart. So you can just leave off the 0 plus because that doesn't change and just write it as k 360. So it's saying from 0, every 360 degrees, you're going to see this point happening. Or just 180 plus k 360 degrees. It's effectively saying for this one, where would the sine graph equal 0? Where is it going to cut the axis? It's going to start at 0, then it's going to be at 180. So the uphill starts there, the downhill, and then another uphill is at 360. So every 360 degrees, you're going to find the start of the uphill. Starting from 180, every 360 degrees, you're going to see the end of a downhill. All right. But we have another version because we had this one as well. So, or theta equals, so you're going to say shift sine of negative 1 in your calculator is negative 90 degrees plus k 360, or theta is 180 minus, careful, put a bracket, plus k 360 degrees. So, sorry, I lost part of that. And so 180 minus a negative 90, we add on is 270. Now, somewhere around, tell me that k is an element of integers. You can put it up here, you can put it anywhere. All right. If you put it multiple places, we're fine with that too. So it's saying there's a lot happening here. You can get a lot of answers for where these two graphs. So it's effectively saying here we have a graph called 1 plus sine theta, and we have a graph called cos squared theta. Where are they going to be equal? Where are they going to cross each other? They will cross at these points. So it's like their general terms for those. All right. So then for the next one, solve for theta if 2 cos squared theta plus cos theta equals 3. Okay, so for the next one, got a cos squared, you've got a cos and a number. Right? It's like saying x squared, x, and a number. It's a trinomial. So we're going to bring the 3 across. And then we're going to factorize. You have factorized in the identities, but just in case you are not able to, you could also say this is 2x squared plus an x minus a 3. And then factorize it into a 2x and an x. And then let's see. So we're going to need 3 and 1, so plus and minus, yeah, so it's going to be 2x squared minus a 2x plus a 3x minus a 3, yes, so it's going to be 2 cos theta plus 3 cos theta minus 1. For those who really suck at trinomials, you could use the quadratic formula here. Instead of solving for x, you'd solve for cos theta equals minus b plus minus the root of b squared minus 4ac all over 2a. So 2 cos squared theta plus cos theta minus 3. There's your a value. Your b value would be positive 1, sorry, and then your c value will be the negative 3. Okay. So then that means cos theta equals negative 3 over 2, or cos theta equals 1. So now in your calculator, if you type shift cos of negative 3 over 2, your calculator says, oh, math error. Now the reason for that is, it's saying where will my cos graph, so that's what my original cos graph looks like. That's 1, that's negative 1. Right? Where will my original cos graph be equal to negative 1.5? Negative 1.5 is below negative 1. There is no graph here. The graph stops at negative 1. So it's impossible for this graph to do anything below negative 1. That's its range. It's stopped there. So for that first piece, there is no solution. So if your calculator, once you've clicked shift cos of a number or shift sine, then if it says math error, it's no solution. The graph does not exist there. Tan will never have that situation because tan is endless bottom to top. But then shift cos of 1 in your calculator is 0 degrees. Now it's supposed to be plus minus 0 plus k 360, but we know 0 can only be 0, so you can either write it as 0 plus k 360 or just k 360 degrees. So it's saying starting at 0, so if we checked where is it going to be equal to 1, there it's equal to 1, it's at 0 degrees. Where is it going to be equal to positive 1 again? It's going to be 360 degrees later. Right, so it's handy to know what your original cos graph looks like and sine graph. So that was a trinomial one. Okay, so then in the next video, I'm going to be putting up an additional note on Google Classroom, which I would like you to look at after I have gone through the type, all right? So rather watch the video first, and then I'll do the complex and co-ratio type. Okay. All right, so lastly, please work on these exercises, 9, 10, and 11. My last video will cover stuff, my second last video will cover stuff for exercise 12, and the last video for exercise 13, and then we're done with trig. So 9, 10, and 11 are with the general solution types. Exercise 9 is the very simple types. Exercise 10 is where you have to give specific answers in a domain, and exercise 11 is a bit of a mixed one with some of those trinomials, factorizing, and where you have to make a tan from a sine and a cos. Please, again, do not use the textbook answers at the back of the book. I will post answers. I'm going to try start on them now. But please, they use a different method. They'll give you different answers. Now, they'll be mathematically equivalent, but they'll look different. So they're going to just confuse you. Also, the textbook examples up to this point, please, again, they're using a different method. So just stick with the examples in this video, and I'll post the answers, and I will post some extra worksheets and things as we go along as needed. But this should be okay for now, and then I'll post the answers hopefully in a little while. Good luck.